What I think I'm going to do with this is to change the these chips. This chip SGS 3525AP, which is if you want to get them from RS, it's that one there. Can you read that? 7147-856. Got one left. I have to get some more actually. I just ordered a big packet of them from LCSC. And then we've got these two transistors here, which are that one for the PNP or NPN, doesn't say, but one of them's PNP. A complementary pair. This is the PNP, so that one must be the NPN. There's the part numbers there. Got that? Got that? Okay, that's some Farnell. Okay, so that's these four here. Normally they don't blow up on these amplifiers, but in this instance we have a situation where the HV has got down into the power supply for this, and you can see. Can you see that one there? You can't see that, can you? Hold on. Yeah, there's a bit of a bad look. Look. So that resistor's been splotted, that one's splotted. They're all 470, I think. Are they? I'll let you know what they are in a minute. I'll have to look on another unit. That's gone. Look, it's got the guts blown out of it. So I'm suggesting that 100 ohm there looks a bit scarred as well, doesn't it? You can tell a lot by looking at things. And this chip's obviously definitely blown, without a doubt. Yeah, and there's my chop out, so I've got to reinstate the 15 volt supply. That one's looks like it's had seen better times. It's explodiated again. And anything else? Anyone else? Check this diode. Yeah, in fact, there's not much in it actually. Quite good. What does this circuit down here do? That's the feedback circuit. I'm gonna have to check that. Yeah, I'm going to have to go into that in a bit more detail. So first of all, I'm going to change all these, change all those, change that, check that, change that, and find out what that is and change that, and then we'll put the low voltage 15 volt supply into this chip and make sure that we've got some FET drive signals coming up here. We've got some 47 ohm resistors to go back in here, do you remember? And that one needs changing as well. So there's a little bit of swapping. I'm going to do it. Should I do it on camera? Is there any point? Yeah, why not? And why not do it on camera? Okay then, ready. So I'm going to turn my buzzy thing on. So that's my hot air gun gone on. Going to get some of the gorgeous flux. If you use this stuff, the old Kingbow, which I've talked to you about before, focusing thing. No. Yeah, RMA 218. If you use it, use ventilation. I don't bother because I'm nearly dead already. Just flux her up. I'm going to flux you up, baby. Right. Where are we? Yeah. Not sure about any of those yet. So let's change what we know to be faulty, and then we'll work our way around what's left, shall we, when we power up and see what's chooching on the board before we hit the big switch and put the high voltage in, because then there won't be any going back. Right. Take it all, bitch. Smoky. Trouble with doing it so you can see it is it blows the smoke directly towards me. Come on. One. Number two. I'm going to check these. I'm going to check these when I get on. One of them's bound to be alright, and I can just make sure which one's the PNP and which one's the PNPN. So I'm going to place them. Oh, well, that's what's wrong with that one. It just finished the destruction that happened, just completed itself and it exploded. Right, okay, so that one there is burnt. you want a closer look at this? I bet you do, don't you? Yeah, you can see what caused this problem with the flying components. Look, the clearly this, whatever's in the capacitor is in. We saw the gassing, the outgassing on the other pad. If you watched the video earlier, you saw the outgassing. Well, this board is gassed up inside. There's liquid, or the moisture is soaked into the actual PCB. It might be an organic solvent from the capacitor or something, but it's you can see there. I don't know if you can see that or not, but the board is delaminated somewhat inside. You can see that patch, that light coloured patch. It's wherever what's ingressed into the board, which has infiltrated the board in the structure of the board, is gassing. Now, I don't normally, you don't get this unless you've got faulty PCBs, and there's a via there, look. See that via? And the board is delaminated around that via. So clearly, I think what I'm going to do is take this board and bake it at 100 degrees C for 3 or 4 hours, just to drive off all the volatiles really slowly, because clearly it's soaked in, whatever it was has soaked into the board. We saw the gassing there, and then we saw this. It's not because the hot air gun's overheated or anything like that, because it's the same temperature as everything is done, and I know a gassing board when I see one. Now I'm going to have to check these vias around here where the gassing's happened, in case the board is expanded and cracked the vias inside, because we know that the vias aren't great quality on this, because we saw them gassing out up here when we soldered these FETs on. We saw all the bubbling and Vesuvius going on there of the gas coming out from inside the board. So what's happening? So with hindsight, it probably would have been best in this instance to do it with the soldering iron, so that it minimises the actual general heating of the PCB, and we don't get this problem with outgassing inside the board. Yeah, a bit more research on that. Anyone got any information on the electrolyte for capacitors and how it affects it when it gets into a circuit? It'd be interesting to know. Anyway, I'm not going to bore you with this. I'm going to put all these components back on, and yeah, and then we'll fire up. Right, I'm going to do these Johnnies by hand, because the board has obviously got gassing in it. I'm going to go and bake it in the oven. We've got an industrial oven. It's going to bake it in the oven for 3 or 4 hours at 110 degrees. Everything will stand that temperature. Electronics does, and then hopefully it will drive off any sort of organic or water-based solvents which are lurking, and yeah, make it work reliably. So at the moment I'm just going to solder these transistors on by hand. 401s are Q6 and Q7. 401s are Q6 and Q7. What's this one? Final part number 1459108. Right, okay, so these are Q6 and Q7. Too much coffee. If I'm soldering iPod connectors by hand or any other fine work, then if I have one coffee in the morning, it's fine. I have two coffees, my hands go all over the place and I lose that sort of very fine motor control, and it's the caffeine that does it. So it makes you feel a bit jittery when you have too much coffee, but you really do tell the difference when you're trying to use very fine motor control. Caffeine, for me at least, definitely doesn't help. Gives me a bit of the yips. Right. Now these, the correct part, this 5550 shares a data sheet with the 5551. It's the same device, and I'm not sure what the difference is, but if you look at all the main data, it's all the same. So I'm fitting these because Farnell don't stock the other one. It's 1653626, but it's a general purpose, fairly low frequency switching circuit in this thing, so it's gonna work. HFE, BCE, reverse voltage, boost emitter junction are all the same. All the same. There's a minor distinction there somewhere. It's on the data sheet, and if you look hard enough, but I couldn't find it. Where did you go? There you are. Where did one go? I think I'm going to have to buzz out a few of these vias. This job just gets bigger and bigger, doesn't it? But if you're stuck at home or locked down, you've got a blown up 518. Need any parts, let me know. Right, that's those babies done. They are all super fine. Super. So we've got 25, 28, 27, 22 resistors. So 27 and 28 are 4.7 ohms. 0805s or 0603s? 0603s, aren't they? I suppose you could put 0805s in, but if you're having an explodiating disaster, you're having an explodiating disaster. What I've learned as well, for what it's worth to you guys, is that in power circuits, when resistors have been overstressed, I had one thing where I didn't bother changing some of the resistors, and it was working fine under test, but then it just kept going. No, they are 805 actually. Yeah, that's the trouble with wearing glasses. You know, these big magnifiers, is you can't tell what's large and what's small. Like reference 0603, 0805. At least that's what I keep telling the wife. Yeah, 1%, 4% ohm, 0805s. Complete with a coffee stain on the packet, I think. If you got one of these resistor books, they're very good. You can't really see it, can you? But all the books come in, all the resistors come in a book. And you just whip them out, and they're, you know, for the amount of money they are, like 25 quid for a 1%, 200 value book with something like 50 of each resistor in there. They are well worth it. Well worth it. 4.7 ohm going on. Too much coffee. Right. Okay. And that leaves resistors 25 and 22. And they are 47 ohms, so it's 4.7 and 47. So two of these. bloody buzzy thing off. Okay, they're in. Lovely blubby jobs. And what have we got now? We have got this one down here. That one there. Resistor number 23. 23 is a number that's been quite lucky for me. Yeah, R23 is a 10 ohm resistor. It was. It's always the low value ones that get fried because they're the ones that are capable of dissipating the power at the voltages. Oh my goodness, I only got 1, 2, 3. I've got 6 10 ohm resistors left in my packet, and I'll get some more. Yeah, my son has just snitched the IPA because he's got a new Jaguar V8 thing, and he's putting some fancy number plates on. And it's quite funny actually, because he said to me, I said, how are you fixing them on? He said, I want to use Velcro. Yeah, and I said, well, Velcro, and they Velcro on so that they can just, like, when they sell the car and keep their number, you can just pull the number plate off and stick your new one on. And I thought, well, it's all very well, but if someone wants to steal it and ring your car, they just pull the number plate on, bit of Velcro, and stick the other number on. So, yeah, convenient for the owners, but bad news for the ringers if they find out. Or good news for the ringers. So we've got R4. Yeah, R3 and R4 are not required because I'm going to change those because of this stupid balancing. It's over here, look. Stupid design. We're going to stick some different ones on there. So we're going to take that off completely. Come on. There you go. R3 and R4 are no longer desired. They are undesirable. Leave the arena. I'm going to change that. I'll explain that in a bit. And we see we've got this horrible wire down here that's been... Yeah, there's a few wires that need checking. So I need to check that wire. You can see that's obviously gone a bit spanky. And I'll put some lacquer on there when I solder it. Oh, C29 has gone. C29 is the timing capacitor, and it's 1 nanofarad, 1000 picofarad, 1k picofarad, 1000 picofarad. 1000 pico, 10 to the minus 9 times 1000. So 0603 capacitors. Back to the capacitor book again. And we're going to get 1000.1 nanofarads out. Here we are. Here's the one ends. So that little Johnny down there, is C11, and that I've checked is connected to the soft spark pin for the 100k resistor from the power supply, the 15 volt rail. This charges up and then stops the thing starting up straight away. So it looks pretty rough, doesn't it? It's obviously been connected to a device that's been destroyed by high voltage. So let's just change that for 100 microfarad, 16 volts. So let's just change that cap out, shall we? Let's put a new one in, noting that the ground 0 volts is on the left. This is like a bit when you take your car to the garage, isn't it? And they say, well, what needs doing on it? And they say, well, you just need to change the bit between the number plates and you'll be fine. This is what this is turning out to be. Right, so that one's blown. I've just been out for a meal with my family, lunchtime, day before shutdown in the UK, the second shutdown, and had some coffee beer. Have you ever heard of coffee beer? Well, I hadn't, and I wish I hadn't. But you know, you can't. When you say, oh, go away, it's nasty, you're stupid, what are you suggesting I drink that for? It doesn't taste very nice, is it? Because once you've got it on the table, let's face it, you've got to pay for it. So in goes a new cap. If you clean that up first. Yeah, so coffee beer. I can't say how many. I thought I might have the idea of, you know, you've got the you've got the beer and the alcohol at lunchtime, and then you've got the coffee, so it sort of might not fall asleep this afternoon. What do you think? Yeah, give this a bit more of a clean. As I say, I'm going to bake this to get rid of all the residue that's been absorbed by the porous membrane, or the porous cheap shitty FR4 grade circuit board. Trust me, listen to someone who's been on the receiving end of tens of thousands of circuit boards for factories that I've run. I was responsible for. Not all circuit boards are the same, and more worryingly, not a lot of people in terms of QA know how to check a circuit board properly. And it's all right if you're working. It's all right if you're working, at low voltages, but as soon as you get some of the old higher voltages, or vibration or mechanical integrity becomes a factor, then you're in trouble. Let's make up a nice dirty solution, then we'll just soak the dirt up with the solution. That's better. I'll stick my cap in now. So putting a new soft start cap in, if we need to slow it down a bit more, we can increase the value of this, so that if our 15 volt supply comes up too quickly before the B plus is up, then we can increase this cap, or increase the resistor as well, which is charging it up, and then we can get a slower start when you put the power on. Trouble is, most of these power supplies, certainly JBL's, they don't really manage it well when the power shuts down. Starting up is one thing, but the quick power dip, power goes away, power comes back, goes away, power comes back because of bad connection, or you're in a pub somewhere down the miles from the end of a pole, lightning, usual power dips and things going on, then you can be in a bit of trouble, frankly, because what's worse than the power going over voltage on some of these big supplies can be the power just messing around, causing an indeterminate state, and then if you keep on driving the power supplies, the voltage, or restart it and stop it and restart it, it's not good. You probably get about 6 months worth of stress in about 10 seconds probably. I'll demonstrate it to you one day. I've got one of these clean power supplies here that I can cycle the power. It's a programmable clean test supply, and one thing you can do, you can wang the voltage up and down like you wouldn't believe if you want it to. And I'll show you the Schaffner conducted immunity tester as well, because that's really entertaining. I'll blow up some equipment with it. You'll find a non-worthy piece of kit that's not CE and hasn't been properly tested. We can do a destructive test on it and just see how many kilovolts of impulse is required to destroy the power supply. So I know you guys like to see that sort of thing. Here we are. She's looking a lot better. Look at that. Lovely jubbly. Apart from that bit. Looks fine, doesn't it? Look at that. Lovely. Until you take that off. Right, so we changed our soft start capacitor. Anything else we've got to do before we go on? We've got obviously to put these in. Got to put the main capacitors in. Anything else look like it's blown? Right, so we've got a blown track there. Is that of any consequence to anyone? No, because it appears to go just here to this power supply. Yeah, so that blown wire, if you look there, there's that wire we were talking about there, goes to that track down to here, to the end of Q10, but if you look at that wire, it comes through here and goes to this cap C16, which I don't think we need to populate. So what is... the question is, what is that track and what does it do? Q10. There you go, back of the envelope, Q10. I've just buzzed it out and it goes something like this. Your live comes in, there's other stuff connected to live, but it goes down through 200k, and it goes down to another 47k. It comes down to a 30 volt Zener diode connected around. Got to get my head around this one. It's connected around that way. That's a Zener 30 volt, and that just goes to the base of a PNP or an NPN transistor. Actually, that goes down to 0 volts. The collector of this goes through a 47k, and it goes to another transistor here, which must be a PNP, mustn't it? I didn't buzz that out, but it's got to be a PNP like that. And that point there goes through a thermal switch, thermal protection switch, just a thermal cutout there, and that goes to your plus 15 volts. So that is the chip supply. That's the, I'm sorry. Yeah. Bloody crap, eh? Yeah, so that is our 15 volt supply we've concocted, going down that way. And this is a switch which comes from live and neutral, so that when you oh yeah, I see. Hold on a minute. Where's that cap then? Is that 1 microfarad? Yeah, there it is. Yeah. So what we also got down here, look, is a 128k ohm there, and there's a 1 microfarad, that's all good to 0 volts, 1 microfarad, 50 volts. So how does this work? Clearly when the voltage on this point goes north of 30 volts on there, greater than 30 volts, this starts to conduct via this resistor chain and turns on this transistor, which pulls that point low. Interestingly enough, I would have expected something like an impedance like that to make it switch reliably, wouldn't you? In there, would you expect a resistor to be in there? But I suppose if there's no current and it's negative biased, it won't conduct, will it? I suppose. Anyway, this is the so it turns on the 15 volt supply to the logic plus drive, like that, and so we've got a time delay thing here, and the power comes on, and it's gonna, this capacitor has got to charge up. It's electrolytic, and it's got to charge up, except that oh, I know. Yeah, that can't work. I was just thinking, because this is AC here, isn't it? There must be a... The only way I can think that can work is if a diode's in that chain. Where is it? That's that track, you know. Right, okay. Yeah, so I think I haven't seen it, but there must be a diode in here. So you've got your AC, charging that up, charging this gap up to a voltage depending on these potential divider of this, turning this transistor on when this point goes north of 30 volts, north of 40 volts, that goes high, that goes low, that goes down, turns on the logic supply to the chip, and turns on the drive to the FETs, alright? So that is a time delay, a bigger time delay than the soft start. So you've got two things. That cap I just put in, wherever it was, capacitor 11, is actually the soft start from the drive chip, and basically the pulses driven out to the FETs will get wider and wider, and the idea is to give it enough time for the capacitors and the load on the secondary side, especially the smoothing caps on the secondary side, to get charged up. Otherwise they'll just appear like a complete short and you'll overcurrent your FETs. So we've got two circuits. We've got soft start, and we've also got a delay start from the power. So it's this one we want to doctor correctly. We'll leave the soft start alone, and we'll make sure that this delay start is working. So this is delay start. Right, that makes sense to you? Yeah, that's what it must be. That's more or less what I buzzed out, I think. I just want to check. So we want to make sure that this connection to live is still there down to these points, and also because this has been connected to the catastrophic voltage over voltage of the 15 volt rail, we want to make sure that transistor and that transistor is still good. This one is probably to be good because it'll be protected by this impedance here. So you know, there's not a way of getting a huge destructive current down through the collector. If this is turned on, this will act as a constant current source, because you're aware that transistors are really constant current source. They multiply the current in the base emitter junction going down there, and without any self-biasing correction, then you end up with basically a transistor is almost like a constant current source until it's turned hard on, in which case it's not in its linear part of the curve, and it won't be a current source. So that's what we've got. We've got that. Right, so I'm just going to have a look at that and see if that's still all connected and the transistors are good. So we'll do a bit of buzzing out here, boys. We're on diode forward continuity. Yeah, that's reading 700 millivolts, so that's right. So that's an ordinary silicon diode. This one must be, hold on a minute. Yeah, this must be, the diode's connected to there, so that must be the base of that one. So if I put the positives on a NPN transistor, if you put the positive diode continuity check onto the base, which is that one I think, you should get an ordinary silicon junction between the 2 points. So I've got 676 millivolts there. So that's the collector, and the emitter is 679. So that transistor is good. So I've got a PNP or silicon diode effectively. I can monitor both junctions, and if I turn that round and an NPN transistor, if you put the black probe on the base, then you'll get no continuity. So that transistor has survived the event. Now this one must be the PNP transistor. So the format, that's the base of the PNP transistor. This time I need to put the negative on the base. Yeah, I've just been checking out these vias, and some of them are okay and some aren't. You can see by this area of the board here where we had a bit of a bulge come on. When we heated it, we got bulge. You see that light green area around here? That's where it's delaminated inside the board, and the gases inside that's been soaked in from the volatiles that gone into the board have gassed out. Outgassing they call it. And you can see that there's this one here is a bit bulgy, so that one's sticking up. You can't see it, but there's a raised, you know, topography map would show a raised spot. And if I just go to the other side, that one's good, okay? Now if we scoot along to the next via there, next to R25, and scoot to that via. So on these, on a boards like this, you can poke a bit of this Kynar mod wire. It's really made for wire wrapping, but you can use it for modification. It's fairly single core copper, fine core, and if I just poke it through the holes. So I bung the wire through. Yep, that is that one. Yep, that is that one. So I should have connectivity between there and there, which there is. If I go along to the other one where the bulge is, R28, and the one along, there's no connectivity. So that wire is blown, and what you can do then is just to put a bit of your wire through like this, through the hole. That one's blown, that wire. That's split open. It's clearly not a good quality board. Fold the end over on one side, fold this over, and then just cut it off. So you end up with a little tag of wire in there. Look, you see that little wire, and you know now that that tag of wire, we've got to solder that end wire on both sides to actually repair that wire. And whilst I'm at it, I'm not taking any bloody risks really, because what's the point of taking a risk? I'm actually going to put a bit of copper through the one next to it as well, because there is a raised area. It could be on the verge, hanging on by a few molecules, let's face it. I wonder what the resistance of a few molecules of copper is. We will never know. So poke it through the hole, pull it back, bend the end over, and then bend that end over, mark that hole up, ready to be soldered and repaired. Right, so there's two wires there and there that need repairing. So let's check the rest of them, shall we? Did hope not to have to get into all this. The other wires aren't in the majorly bulging area. The most suspect one is this one down here next to Q6. Alright, so I'm just going to go on the other side and meter that. Well, that's good. As I say, that's not in a bulgy area, so I don't expect that one to have gone, unless... Now this one has gone. If I just show you this one here, is it that one there? Hold on a minute, there's two. There's a lower one there. You can't see any of this at the moment, but it's difficult to show this on film. So that lower one's good, but the upper one, yeah. Oh, that's good as well. I wonder if that's connected to the track though. Let's go to there. Yeah, that's about it for suspect wires, I think. I think we know our suspect wires now. We've got two dodgy wires, which we are now... Actually, I'm going to do that one as well, because that is in a bulging area. So clearly, you know, if you just turn this thing on and you've got your wires open circuit in a high power supply, 500 watt switch mode power supply, probably not a good idea, eh? So let's just reinforce the wires, then we won't have any trouble later on. See what happens if you complain. Yes, talk about people being afraid to express their political views on the politics front. What about marriage? Husbands' lives matter. No, my wife is fantastic actually. I'm just parodying. It's more of a parody, but it's not true because mine's absolutely lovely. Right, so they're all soldered on this side. Let's turn them over and solder them on. That one doesn't want to be soldered onto there though. Right, let's turn them over and just solder the other side. So we're just going to give these reinforcement for the wires. You know, when you're repairing power boards that have had a bit of an incident, if there are wires, then they will invariably let you down. And invariably, if you don't check them, you'll turn it all back on and fut. Something won't work properly and you'll get an overcurrent or a bad condition and something will get destroyed. And you're back to square one. So why not just spend 20 minutes or so just repairing damaged wires, is my advice. Hoping for the best doesn't get you the best, it just gets you another shitload of work to do because it's blown up again. Okay, so trim off the tails, make sure they're not shorting on anything. Plenty of clearance there. These cutters, incidentally, All-Star UA91340 are from Banggood, and they're $5 a pair, and they are bloody good. They are bang good, actually. These cutters, if I can find them. Those buggers gone. If I come across them, I'll show them to you later. Yeah, these cutters are about £50 a pair, and I've had these for like 25 years at least. And look at that. That's, I don't know what make they are. Lindstrom or yeah, Lindstrom, Swedish. They are bloody fantastic. I've mistreated these so much, and they're still sharp, you know. Fantastic pieces of kit. And if they ever broke, I would go out and buy another pair of Lindstrom to replace those, because I love them so much. Oh, I don't need fast cars or motorbikes. I just like a nice pair of cutters. When I used to recruit engineers, I used to show them nice tools, and if they just sort of picked it up and looked at it and looked at me strangely and put them down and didn't appreciate what they were, then that told me, spoke volumes more than I'd hear in the interview. Because I was trying to recruit dyed-in-the-wall engineers that just eat, sleep and drink engineering, rather than guys saying, what shall I do as career choice? I know what I'll do electronics, because I like little PlayStations and Nintendos, and of course they never really get anywhere. They end up in application support. Sorry guys, but you do. Right, okay, or sales, even worse. Right, so we repaired our wires. Every component, I think we've got to replace these, haven't we? These 47 ohm, these big 47 ohms down here, I've got to find from somewhere. And you can see, you know, I said it was bubbling the board. Look, can you see where it's delaminated here and here as well? Well, all those bubbles are coming up. So the wire has cracked inside, or is porous, even worse, wasn't plated through properly. And then when you heat the board up, the gas has got to escape out of there, so it blows up through the wire and makes up those little Vesuviuses. So look out for that. If you see gassing, be careful. Bake your board before you power it up, is my advice, especially if you've got any high impedance circuits, otherwise it'll be curtains again. So finally, R3 and R4 I took off because that was that nasty. I've got to change that circuit there, that and that, for the protection for the capacitors, because these have always got these caps completely, you know, explodiated. This one's let its guts out basically, and it's always on these boards because of this problem with the cap balancing. Abysmal design, don't tell anyone. Yeah, so we're feeding our 15 volts in to the emitter. No, I think we'll feed, I don't know whether the bootstrap supply is still intact on this or not, the actual diode rectified bootstrap supply. Should we check that out and see? That would be somewhere near the transformer, will be a diode. This one, that's the bootstrap rectification diode. We bootstrap Jimmy. Booty straps. What is going on here with all this bloody cabling and crap in the way? Oh, that's better. Yeah, check D8, bootstrap supply diode. That's weird, isn't it? Dark low. Oh, I've got to power control the light. Megalomania. Right, so diode continuity again, just check the bootstrap supply is actually going to provide any juice. No, diodes. Oh no. Come on. Yeah, 500 millivolts, not quite Schottky, not quite silicon rectifier diode, 500 millivolts feeding into the collector of that transistor, which will be the switching transistor. Coming down now. Let's see if it's connected to down here then. So that in theory should be connected to there. No, it's not, because the track's missing. That's the base, isn't it? The collector of there, the emitter. It should be the emitter of the PNP transistor we changed, which is that one, or that one in fact. That one. Yeah, the track's gone. Yeah, we sliced right through the track, that's the question. Well, that's the problem. So if we reinstate a track coming down from that point there, is there a reservoir capacitor on that supply then? C16. I've got on my notes C16. That one. So that's the reservoir capacitor. So the positive side of that reservoir capacitor, which is that one, should go down to here. No. There. No. It goes from there to that via. So from there to that point. The wire's gone. Look, you can see. That's that track we were talking about that had etched. Do you remember? Etched away from there to there. A blob of capacitor spit had got on there. It caused some kind of chaos, baby. So yeah, that's gone open circuit. But normally, if I poke hard enough, you can find it, and it goes down here to there. That's where it should go. So we need to repair that track from there to there. From what's the matter with this bloody exposure on this soldering thing? Spot meter. That better? Yeah. Yeah, goes from there to there. Sorry, there should go to there. It doesn't, but if I poke around, I'll get my tip down the hole and I can get it, but not. So that's blown open circuit in there. So what we can do is reinstate this capacitor. This should go to AC 0 volts there, which should be on the chip, according to the data sheet on the chip, is ground, which is pin 12. 16 pin, 16, 15, 14, 13, 12. Yeah, it does. So we'll put 100 microfarad capacitor in there, a 50 volt one, 25 volt one, 50 volt one. Ah, you see, yeah, that goes through a 12 volt regulator and then drops through a diode, I think. So that must have been a regulator chip for the bootstrap supply. So I don't think I'm going to reinstate that bootstrap supply. I'm just going to put my bootstrap supply, which is pre-regulated 15 volts, which will drop down through the protection, the reverse flow diode. We've disconnected all the electrics that go to the center point of the capacitor, so we've alleviated somewhat that bad loading problem we could get with the dragging down of the point. If you look at the original 318 video, that was the problem. So yeah, I think I'm just going to put these resistors on. I'll dig out these resistors, put these back on, check that one, and slot the caps back in, and we'll be ready for rock and roll, won't we? What do you think? Ooh, brown trouser moment coming up, boys. 500 watt power supply reinstated. I only wish I could. I might take this off here completely, undo that, and then clean out in there a bit. I think that's what I'm going to do, because it doesn't look very nice, does it? It's horrible, and I don't know how conductive and nasty all that crap in there really is, to be honest. It doesn't look good. Right, so yeah, let's give it a bloody good clean, and I'm going to reinstate that cap anyway. That'll be a local decoupler for my supply, won't it? Just in case there's any funny shit coming down the wire, we can alleviate that by putting a cap on there. So I'm going to put C16 back in, but not reinstate these tracks to this part, because that regulator chip there, is that the regulator? That should be normally a 12 volt regulator. Yeah, 7812. I could put my regulator on there, couldn't I, and use that rather than hacking it onto the other board. Never mind. I could have had a rough DC coming in here and then put the regulator if that regulator was good, I could have left it on there and used that. But ho-hum, you know, next time. Okay, 47 ohm 2010 resistors. Have I got any is the question. I'll go and find some and come back to you. Right, 47 ohm. I've actually got some, look at that. In stock. Can't see that, can you? You can't see that. 47R, 1%, 0.75 watts, 2010 thick film. That one there. So we want 2 of those. Let's remove this claggy solder with a bit of solder braid. Clean it all up. And these two 10k resistors, look, they don't look very happy, do they? They've obviously got some of that capacitor guts on them before things went totally south. I'll change that as well. Unhappy resistors. There you go. Lockdown restoration. Okay. Right, there we are. In there. Where did the other one go? Fired over there. Lovely. Beautiful. And then we just need 2 10k 0805s. 0805 book is right, a couple of 10ks. 10k. This is in the gate drive circuit for the FETs. Looking very fetish at the moment. If you're looking at where that is in the circuit, I'm surprised that does anything at all, that 10k resistor. Right, okay, so let's put those on. Now after we put these FETs back, we need to make sure that there's anything on the other side is connected okay, i.e. a good well of solder, because if any of those wires have failed in those holes, I'll show you what I can see in a minute. I've just spotted something. Okay, so there's 2. Let's take this heat sink off because I don't like it. Don't like it. Isn't the right one for that. No, that's not the right one either. That's a positive drive. No bloody good. What we want. Try a Phillips, shall we? Not that one either, so it's got to be a red one. A red Phillips number 2, do you think? Yeah, look at that. Fits like a... lovely. Okay, here we go. locking stuff they put on is bloody evil. Sheer evil. Hello. Yeah, it was very dark.
Now I'm going for a massage and then Pilates, and I'll be back.
Okay. I can't wait. Is that a promise? Oh, I have no idea.
So is Leslie coming back today then or not?
Who?
Leslie.
Don't know. It's anyone's guess.
Oh, okay.
Not sure. I'm not on the must be informed list. I'm need to know list.
Who's then?
Hello.
Hello.
Do you know what? I might be lucky tonight. This might actually work. No, that wasn't what I was talking about either. No, that's not right. Got to take the screw off this. I'm just going to clean this out because I think I'll be happier if it's clean. Get those lovely pair of Lidl pliers. Grab hold of the nut. Yeah, if you try and get these screws out with a Phillips driver, not with a posi drive screwdriver and not a Phillips driver, I think you're going to have a bit of a struggle on your hands, to be honest. Right, so that's what that looks like. Not nice. There's a screw that holds the rectifier in. Where did the nut go, everybody? Anyone see where that went? And I put it up there. Maybe I've already moved it. It's certainly not in there. Okay, we can get a better look at the top side of her now, look. There you go, so down here. Yeah, there's nothing, as long as I make sure they're soldered properly on both sides, we'll be fine, I think. Let's pull her drawers up, see what she's like down there. Let's give her a clean under there as well. Right. Interestingly enough, you know, when we used to do a lot of PCB population, the PCBs would come in a vacuum seal packed, where they'd been packed dry, and if they'd been left open on the line or something, then we'd bake them, give them a good old bake. Right, so you can see the lamination where the bubbling was happening, and actually if I'm looking down, and I know I didn't do this damage, but if I look down those holes I can see the cracks in the wire, especially that one there, you can see where it's been blowing through. Right, so they're all reinstated. Anything else need doing? Check that diode. We check that diode. We check this diode, although that's not used. These aren't used anymore up here either, because they're not connected to anything anymore. And we've taken those out, Right. Reinstate the FETs and the actually, I'm going to fire this up. Initially, I think I'm going to fire this up without the FETs in it. That's a good idea. What do you think? Yeah, because if we fire it up without the FETs, we can just check that there's drive, can't we? Yes, we can. And then we won't be embarrassed. Right, so caps and protection. Now there is one cap dangling around, so I've been testing it on my capacitor tester for a week. Where's it gone? Yeah, I bought some caps online, and I've left them connected to my cap tester for a week. at working voltage, and it measures the leakage current. I bloody lost it, haven't I? It's probably fallen off and rolled around somewhere. Leave it with me. Right, the protection circuit, the balancing circuit going on. Have to be metal film resistors because I don't have any other ones. There's plenty of, they're good voltage resistors, and they not much power being dissipated in them, so they're fine. They'll be fine. That one I'm going to put a bit of capped on under there. Capped on, capped off. Capped on. There, like that. You can buy about 5 or 6 different thickness of rolls of this capped on tape for about 5 or 6 quid, and I recommend you get some. It's good. Phenol based tape. High voltage, high temperature. Lovely colour. Gives a golden look to your electronics. Right, I might put a blob of silicone on this construction after it's finished. I'm not sure at the moment. Right, so that's going to stop the capacitors blowing up, and then we need some varistors, don't we? Where are you? You little buggers. Yeah, so I've got a data sheet, and this is again LCSC, about 5p each or something. These aren't surge protectors, they're just to stop that imbalanced drift that goes on, to get these caps drifting out and then blowing up. Alright, so that's another failure mode on these things. So one of these each across the capacitor will stop any funny business. I'm just going to stand that off the board, I think, and put some silicone on it. Oops, get down there. Okay, stand it off the board slightly. A little blob of the old white splodge on there will solve that problem. Vibration and wear and tear due to mechanical challenges. Right, solve that one on. Not the neatest job, but it's the electricity that counts. Come on, baby. There we are. Take it all. There we are. Lovely. Give her a good hot bath before we turn her on. Right, lovely. Right, so it's going to stand off the board so it can't short, and then this one, where we're going to mount this one. I think there, don't you? I think I'm just going to put a bit of Captain on that one. More Captain. Nothing it's going to short on, but you know, best to be cautious. So these are intended to stop the voltage on the capacitor over voltaging due to this drift issue. I think because we've taken away that stupid bootstrap supply they put on there, we'll have mitigated this problem. But these caps are expensive, and the repair is even more expensive. Okay, going to finish this off camera. I was going to have a cup of tea. Yeah, so they're soldered on and insulated from the board. If you want to know why they're on there, why they've been added to the circuit, then here's your reason. Everyone's the same. If you want to repair it, make it reliable, give the customer a good job, change them caps, add the 82k resistors and the 200 volt DC working varistors. They'll start conducting a little bit of current before 200, which kind of head it off at the pass, but now we've got 250 volt capacitors fitted. You know, better than the factory, eh? So, yeah, I think, yeah, it's going to be connected up and fire it up time. So what I'm going to do is I'm going to run 15 volts in from my power supply to start with, across which cap where. Yeah, it goes onto that line, doesn't it? See where that is etched away, that varistor, right next to the, is that high voltage? Christ, it is, look. Thank you very much, everybody. 250 volt line. Okay. 20 volt supply, look. No wonder it bloody well broke down across that thing. There's like, I don't know, well, actually 160 versus 20. That's why that's got some capacitor spew on it and it's burnt out. So, I made a mistake here, haven't I, really? I should have, we put an extra decoupling, there's the decoupling cap there, was that? That's the decoupling cap for that one, and that's the startup, that's the slow start. And that one's the decoupling for our supply, and then the track comes down from the supply. Is that track there? Oh, okay, that goes in by the regulator and out from the regulator. Is this the 0 volt rail? It is. No, it goes right past that track, right in that spot. So I'm going to cut a good section of this out. And C16, that's the one on the top. Yeah, so this C16 is not connected at the moment because the track's burnt out. Can't connect onto there, but I want a nice robust place to connect onto. Where else is there? It goes to the emitter of a transistor and a few other components on the end of D7, which is one of these, which again is not connected to anything. D9, there's D9, still not connected to anything. C16 and D7 goes down to that point. The other one went down to a track to this point here, on the other side of the switch, which is this track. That's the thermal switch in the 15 volt line. So the 15 volt line goes up there through the thermal switch and back down to here. But that's after the slow start, so we have to go in on this track. How close does it get to that track under there? Oh, that's okay, but what a shit design, eh? So we need to at least remove that bit of track there. I should get the Dremel out really. US presidential election today. Anyone know what's going to win? Anyone got a bet on? I have. I haven't told you I bet on though. Right, so we've made a nice big gap in that track. Not very pretty, but it will stop it shorting out. Now we've got to find a way of connecting onto that point reliably. And also putting a wire in. I know. We'll put a link wire in from there to there, to the positive side of that cap, which is C16, which is the decoupling for the supply. Yeah, we'll put a track down from a link wire from there to there, bypassing this with some insulation and avoiding board tracking like that. And then we'll put a wire in, then we'll connect on to check our power supply. Actually that wire has gone, isn't it? Do you remember that wire there has gone? So it's supposed to be connected to the positive of that capacitor somehow. No, it's not. Right, that's 0 volts. That's no good. That's the 0 volt leg of the capacitor then. Have I got that in the wrong way around? No. Guys, look how close that is. Design review, boys. No design review on this before it was made. Yeah, that track on that's 0 volts and that's 15 volts. But look how close. Yeah, so anyway, so run a track down from there to this point on a wire. I'm going to link wire down from there to there, anchor it to the board, and we'll solder our incoming wire from our 15 volt supply onto that pin. Plan has been approved. Still pretty close to that track, isn't it? That's 300 volts. Bloody www.shittydesign.com. So how does that get to that buyer there? That's the question. Oh, I see. That Jesus, it gets worse. That steps out to there over that track to bridge this gap here, and then it's actually well under the edge of the capacitor, and they put it right next to the 300 volt line. Jesus. I've said this before, but when my engineers, when I was a technical director, used to do that, I'd call everyone round and see if anyone could spot. They'd be there with their CAD design on the screen, and I'd look at it and think, oh geez. So then I'd call everyone else around and say, can anyone see what's wrong with this? And then they'd all say yes or no. Bit of embarrassment for the person involved, and the worrying thing was when everyone else could see it and the guy laying the board out couldn't see it, because we worked on rapid development, so for blue chip projects, most of them, and everyone used to lay out their own PCBs, so you'd do the whole thing. The guys did the schematic, they did the firmware, and they did the PCB layout, and we wouldn't employ anybody that couldn't do all three, because they weren't proper engineers. You know who you are. Yeah, so that's what happened. You can't guarantee that no moisture will get onto the board, that's the problem. If you think about a warm environment, warm, humid, near 100% humidity environment like, I don't know, Malaysia or somewhere, and then it's nice, and then the cabinets are vented because they've got little air holes for the base reflex or whatever it's called, and then you take it in for the gig into an air-conditioned hall, low humidity, 20 degrees, medium humidity probably, and then the cold air wafts into the cabinet, and then all the moist air inside the cabinet doesn't get wafted out again. As the cabinet cools down, the condensation starts, and you get like a layer of moisture over the board, and then that's when you get the breakdown between closed tracks that are positioned like this. But Jesus, I'm going to put some put fur on this rather than the other stuff. Where is it? There it is. I started telling you a story about PTFE the other day, and unfortunately my bloody microphone was switched off. Well, not microphone, the camera. And the story goes something like this. Long enough? Yeah. Yeah, we're working away, and we'd seen this thing that said if you're machining PTFE, the dust can be quite dangerous. We thought, well, yeah, it's like inert stuff. You could chew it, you could, eat it probably. And I thought they used stuff like PTFE, or is it polypropylene, for your hip joints and things for the socket. And as it turned out, the this guy was turning down making some insulators for a radar set out of PTFE, out of solid bar stock material, 1-inch diameter PTFE, and it was a high voltage insulator that basically it was a, I forget what you call it, when you go through a bulkhead, yeah, a bulkhead feed for a 20 kV supply. Anyway, he's machining these things down, and then he comes back and says, I don't feel very well, you know, I'm not feeling too good. So, you know, poor chap, go home. And then later on, we heard that he was actually in hospital. And he said, what have you been working on at work? And he said, oh, PTFE. And he said, oh, were you smoking? And of course, those days you could smoke on the job. You know, everybody had an ashtray by their bench. It was not manly not to smoke. And yeah, PTFE dust gets on your cigarette, you inhale it, it burns. It will burn at, you know, high enough temperature, 800 degrees or 1000 degrees, whatever the end of the fag is. And it makes phosgene gas, which is highly poisonous. So you take a puff on your fag, there's a little bit of PTFE on the end of your cigarette, which you used to prop on the side of the lathe, and there's all bloody shavings flying everywhere. And ill, very ill, hospital for 2 weeks nearly. So the moral of the story is, don't smoke if you're machining PTFE. Right, so we've got our link wire in there with a PTFE insulator, so it can't short out on any of these tracks very easily. Not happy about that really. I might put some lacquer on there, but we certainly need to clean this flux residue off, don't we? Yes, we do. Okay, so put the FETs, I'm not going to put the FETs back in, I'm just going to power it up with a 15 volt supply at the moment and see whether we've got any switching and stuff going on, see if it's basically working or not. Yes. And the positive rail goes, let's do that. Lovely. I had a bit of wire here. Now, positive rail goes onto that part of the capacitor, the other supply line. So this is where my 15 volt supply will come in to power the beast. Check the polarity twice, turn it on once, or check the polarity twice and repair it once. Right, so that's where our 15 volts. Let's turn the scope on. You're going to get some more noise. Sorry about this. Scope probe. So what we'll do, we're not doing any precision measurements. So I will take the blue probe, that's this one, and use the earth clip off that to clip onto the power supply somewhere. There. Negative's the yellow wire. Negative's the yellow wire, that's correct. Right, so scope is pseudo grounded. We'll see a lot of noise on it because it's not coming. The earth isn't the same lead as the actual scope lead, but I just want to see if I've got any FET drive and what sort of currents the thing's pulling before we start taking big risks with this. Oh, so it's gone up to 15 volts and we've got a current of no current. Ah, yeah, that's because that bloody supply's not turned on, is it? Because there's no mains coming in. I didn't think about that. Well, we've got 15 volts on there. Yeah, we've got 15 volts on there. Nothing on the FET drives to take it. Power supply. Oh, wait a minute, no. No, it's got some hum coming up channel 2. It's weird, isn't it? That's channel 1. Come on, turn off channel 2. Channel 2, you can go. Thank you. No, it's not doing anything. There's a little bit of hum on there. A little bit of signal. A little bit of a signal. The FET gate drive is this point, which we've got nothing on. We've got nothing on. Nothing, nothing, nothing. And I think that's because we haven't got any 15 volts on pin 15 yet on the chip. Pin 15 is a VCC. No, we've got no power, boys. That's because this switching circuit I showed you that ran off the mains. Do you remember? You have to go back to see that. What did I do with it? Somewhere I had it on a bit of paper, didn't I? On a fag packet. Yeah, I fed the power in here, and this is switched by this high voltage line here to this transistor. So I need to put a small voltage on the base of that transistor to turn the bloody thing on. But it's useful to test that part of the circuit, don't you think? Let's find out where I can hook into it. So I want to hook into, that must be, the one I changed was that one up there, so it must be Q6 is the one I'm looking at. Q9, sorry. Q9, it was upside down, yeah. Q9. So I just need to ground the collector of Q9 and the thing should fire up. Shouldn't it? That's that one there. That one there. So I just want to put a link. Yeah, if I link out these 2 points, basically what I'm going to do is just stick a link across there. Will that work? Yeah, that'll just drag this down through the emitter base junction. No, 47k, not too much current. Pull this down, turn that transistor on, and we'll have our 15 volts. So let's just turn the power off. Get a piece of wire and link across that transistor. Remember, this is the switch which turns off the power when the 20 volt line, the low voltage DC to the chip, when the power supply line turns off or turns on. It's a start delay, but the trouble is it won't stop a full start when that capacitor, the time constant capacitor, is charged. There's nothing when you turn the power off at the glitch to discharge the capacitor and reinstate the soft start, is there? Or delayed start. So another schoolboy design error, if you ask me. Base emitter collector. Don't you think? Yeah, a lot of trouble. I mean, this is more interesting for me really, because it's a bit of a challenge to get something working, and also because this guy is a new customer and I ain't going to ship him anything back that I'm not 100% confident I've done everything I can do to make it reliable, plus the fact it's probably going to be the most reliable 518 speaker on in the marketplace by the time I'm finished. Yeah, so we link that transistor. Can you remind me? If I forget to remove it, leave it in the comments. It'll probably work. Alright, so we turn the power back on, and this time we got any current flowing? Yeah, we got 20 milliamps. 2 milliamps, that can't be right, can it? No, it can't be right. So have we got any voltage on pin 15 yet? Yeah, so the transistor, the actual switching transistor, you can't see this but I can see it on the scope. Just let me tell you that that is conducting and there's power at this point, but that power from that point is not reaching the chip on pin 15, so we've got a blown wire somewhere, I think. Probably the cause. 1, 2, 15. No power on pin 15. So how does it get from there? This is the question. How does it get from here to there? Hello? From there. So the collector, it goes through this bloody thermal switch, doesn't it? Remember this thing? Boing, boing, boing. This thing, this thermal switch. Shouldn't have blown open circuit. I suppose, yeah, it could have blown open circuit because the grief came firing down the wire through that switch, didn't it? If it fed back up the 15 volt rail. So check your thermal switch. No, it's not that. It's not a thermal switch. Let's just see if that thermal switch is actually switched on. Let's turn that off. So we're taking 2 milliamps so far. That's better than none. It's 2 milliamps more than we had a minute ago. Which wires is that soldered into? Is it these ones? Yeah. So you got your thermal switch is good. Or is it? Yeah. Thermal switch has survived. And that output of the thermal switch goes to there. Alright, so we've got our pin 15 thermal switch supply. So the input to thermal switch goes to this point here, or it should. Look at that, but it doesn't either. So what has blown up? What are we missing? Oh. No, it's not that. How did it get from over there? Right, so to recap, we've got this solder bridge across there which is switching on the delay start supply from 15 volts via that transistor. So that transistor is now conducting, and we've got that transistor is behaving itself. Then we've got the, I'll move that wire out of the way, we've got the thermal switch here which goes to there, delivering its power to the 15 volt via the thermal switch right over this side, and then the other side of the thermal switch goes to that point there, which goes up to this point here, that via. So if we just poke something through that via, that one there, see where it goes. Ah, it goes up to here, look, see that wire poking out through there, and then and that track is completely gone, right? So there's another wire we need to reinstate here from the thermal switch to the 15 volt supply off the collector of that thing right bloody under there, which is annoying. Right, so that goes from under there all the way down to this point here. So let's take it away from the transformer. Let's take it away from that bloody high voltage connection as well. Right, gonna have some Captain onto there. Bloody thing. Not nice design, you know. This would give me nightmares if I was rolling this out. I bet the engineer that designed this doesn't work for the company that designed it anymore. I shouldn't wonder. Should we? Come on. That's it. So where are we going with this? We're going to go to, did I say, which side was it? This point here. We'll keep it on the low voltage side of things. It goes on to that point there. What can I say? What can I say? It's just poor. Okie dokie, so the thermal switch is now connected to the switched 15 volt line, let's call it that. We're going to have to separate that off there and hold it off and put some silicone on to stop that wire, keep it away from the, actually that's 0 volts, is it 0 volts? Yeah, that's the midpoint, so yeah, that's 160 volts higher than this point really, or 160 minus 15. Alright, so now let's put the power back on and see if we've got any signal. Right, okay, now we've got 17 milliamps now, so there's more current being drawn. So look on the gate, nothing at all. That gate, nothing at all. Oh, did that just fire? Nope. Still nothing, but anyway, we've got 15 volts on our chip now. Yes. Oh, okay, I just thought I'd insert this. This is the sort of example schematic from the data sheet. But it gives you a pretty good idea of what's what and what's where I'm talking about. You have to refer back to this if you want to have a look at the pins, or just take a snapshot of this or open it in another window. Yeah, so we've got 15 volts on there. Yeah, let's move that down. I'll get a better idea of the voltage. If there's anything interesting appears on the scope, I'll let you know. Where are we? We've got 15 volts on there. That's disappeared now. Pin 8. So we should have like 15 volts on pin 8 at the moment, all things being equal, unless that cap has blown. I think we didn't change it, did we? We said we were gonna. Yeah, we've got high voltage on pin 8, so the chip should have started running by now. So what we got on the clock? Oscillator pin 4. This should be the clock output from this chip. Nada, nothing. Yeah, so let's find out why this thing's not chooching, shall we? Set the brightness right. I'm going to put the data sheet of the chip, so note to self, put the data sheet for the chip on the board at the moment. I just resoldered the chip wires just in case I was making a cock up. So going through the pins one by one. There you go, so I've got 5 volts per division. We're working now. So on pin 15 we've got the voltage from our switch 15 volt line, which is there, and also it fed through, I think it was a 10 ohm resistor on the board to pin 13, 16, 15, 14, 13. That's there too, that's lovely. Soft start is pin 8, which is that capacitor discharge thing, that soft start. It's coming through that 100k and this capacitor here, so that must be that connection there. It is. It's at what, 6 volts or something like that. 6 volts. It hasn't swung all the way up to supply rail, but I wonder. Probably doesn't. It's probably limited. Okay, there's a current drain on the input pin, I expect. So that's working. And now if we go along to the clock, looking at the data sheet, 4 is the oscillator. 1, 2, 3, 4. Ah, no oscillator. Okay, so there is. I changed the resistor, didn't I? No, I changed that 15k resistor because it looked a bit manky because it had been chewed up. Do you remember? And then one end of the 15 volt has got steady, so the clock is not running because that is part of the actual timing circuit, the charge discharge of this one end capacitor. So if I got the value of that one wrong, although it should be running, so the other end of that should, according to the circuit diagram, go to, on the data sheet, should go down to ground. So that's the discharge to ground switch, and it's not. And it's not gone to ground, 0 volts. I keep going ground, it's an old fashioned thing, isn't it? 0 volts. AC 0 volts to be totally accurate. Yeah, see what I mean? That is a blown via. It looks a bit dodgy, doesn't it? Don't see that bit there? That is a blown via. So yeah, 1, 2, 3, 4, 5, 6, 7. Yeah, so we've got no discharge. So the actual cap charges up, and there's no discharge. That's supposed to be. Oh, did you see that? I poked my scope down the hole and it came back. I put my scope the hole in this. If I reinstate the VR, yeah, if I reinstate the VR, the supply current's got up to 53 milliamps now. It's running, so it's that via has gone where the heel. So I could ship it back with the scope probe stuck in it, or I can put a wire in there, can't I? Can I get to the other side of that thing? Yes I can. Or can I actually? Yeah, just about. Right, let's put a wire in there then. That's what the problem is. You've got a blown wire. See, that's the benefit of starting it all up without any high voltages on the board. You can see what's not or what is going on. It's the Trump election today. Are you pro-Trump? Are you anti-Trump? I'm pro-Trump, otherwise I get very bad indigestion sometimes. I think the Brits will understand that joke, but possibly it will be lost on quite a few nationalities. Because as everyone knows in the UK, to trump is to break wind, basically. As in Urban Dictionary, core, who's trumped? I suppose it's a bit like a trumpet, isn't it? So playing the trouser trombone, I guess. But anyway, I don't know if he's going to win or not. I was contemplating watching it all night, but do you know what? I just don't think there's going to be any results. It'll be the Democrats burning down the cities in protestation because they don't have any integrity, let's face it. There we go. Via 715 has been reinstated. Just cut that wire off. Stand my capacitor back up. So this 1 microfarad down here, this one, is the only one that survived on the whole board on the live side in terms of electrolytics anyway. Electrolytics. So now when we turn the power on, we should get 53 milliamps. Oh, we do get 53 milliamps. And shall I see if there's any drive on the FETs or not? It goes to there, it goes to there. Yay! We have drive, baby. Come on. You can do it. Come on. There we are. Is that going to go? Come on. You're seeing just a line, aren't you? I'm not. I'm seeing all sorts of lovely stuff. What's it doing now? Oh, I see. This isn't. This is what you see. That is very strange. That 10 microseconds. 10. There you go. That's what I'm seeing. Isn't that lovely? So horrible thing. It's transformer drive, and there's no capacitance of the FET gate on there because there's no FET fitted right. I'm poked in the heel down here. So if we look on this one, and there's a complementary drive, not the same voltage, worryingly. Oh, I see. Yeah, because that's not ground. Okay, I think that's all right. So that one, and that on the other one. One's impressed on the other because it's connected to the midpoint. I think. Yeah, that's a couple bar resistor to the midpoint. I think that's okay. I think we're going to be all right. So, boys and girls, if you're watching, I hope you are, because I know some very capable female engineers. I've worked with one called Tanya for years. She was fantastic. Didn't take any crap from anyone. Did the job. Knew what she was doing. Superb engineer, actually. Right. We're going to put the transistors in now. Let's turn that off. So we can run this power supply. I'm just looking on the front of the power supply. It says you're allowed to be 240 volts DC to ground. So we could put the FETs in and run it off this supply before we wire in the full Monty. So here's the FETs again from IRFP460s, again from lcsc.com. Half the price. The movie. Slider in. Lovely. Yeah, they're a bit slower diameter. I can see whether they've waked up on the other side because I don't really want to rely on the connections on these wires. Although, having said that, I don't think there's any tracks emanating on the other side, so they've done one thing right. Well, yes, there is. Look, there's this one. And the components falling out. That wasn't very handy. Come on, and go back in now. Lovely job. Yeah, these FETs have got diodes in them. They are ESD resistant as well. So this thing, you know, if someone said, "Oh, well, you're not wearing a strap," look at that thing. Look at that wire bubbling. Got a very bubbly wire. Yeah, you're not wearing a strap. And I thought, well, you know, most of these products, the components these days are ESD protected. That's all I'm going to say. One thing when you solder these things in, you don't want to bend them afterwards really, because bending them, you're putting a stress on the leg and it's pulling on the package. As it heats and cools down, that's what causes little bonding wires and things to fracture off. So component lead forming and having a happy component sitting in the board is quite important. Right, okay. Okay, it's been a long old slog. It'll take me half an hour to put this back together, I think, once I get it working. What do you think? I think I'm going to let this dry off. That's it finished now. When I turn the power back on, with some real beans on it, some juice, it should run. But at the meantime, let's clean off that chip because it's got a load of flux on the surface there where I soldered those legs. Yeah, so three blown wires, a blown up track, a completely fried area from that stupid high voltage linear bootstrap supply that is still switched on when the switch mode power supply cuts out. New chip, all new transistors, all new resistors down here, new components down here, this one, that was okay, they're all okay. The balancing circuit put on to keep these capacitors in whack. 200 volt capacitors changed for 250 volt, which is what they should have been in the first place for the UK power supply market, and with this stupid imbalancing circuit in it, which they've tried to correct, I think. There's a couple of iterations of this board, and none of them work properly. Alright, so I think before I put any high voltage on this, I'm going to take it down to the workshop. I'm making some bread later on. You've seen my sourdough loaf video, presumably, and I'm going to go and bake it in the oven overnight, maybe 100 degrees, to drive off any of this crap from those capacitors that's got in there. And I think I might give it a quick lick over with some conformal coating before we box it up, because the track and gap stuff is not great on this when you're thinking you might get some condensation. Yeah, it's a power supply worthy of a 500 watt caravan inverter for 30 quid, to be honest. Not a £500 loudspeaker. But you know who you are, and if you want me to appraise and fix your designs and make you the leading manufacturers, I know it ain't difficult. It's not rocket science. You just have to apply yourself, and don't take the word of the engineers that are working for you, because unless you know that you can trust them, the chances are you don't know as a manager whether they're pulling the wool over your eyes or not. And that's the big problem with all these technical things that go wrong. It's like the UK government keeping all the COVID-19 test records on a bloody Excel, on a 60,000 column Excel spreadsheet. And the reason they gave was, oh, we put it out to tender and we're waiting for a £1.9 million tender to come in. And I said, well, you know, anybody, you guys that are software engineers, would know that with an SQL database, Microsoft SQL or whatever, SQL server, and you know, a VB or VC or Java front end, you could knock that up in a day. Spreadsheet, really? 60,000 columns, really? Lost 16,000 tests? Nobody's been fired. And I could have done it in a day for them, because I've done quite a lot of database programming. Yeah, so that's it. Got to support that wire before we put it back together. Vets are in. That's not very clean. Yeah, we're going to put some lacquer on this. Give it a chance, eh? Because it does come from up north, this one. No, it doesn't actually. It comes from the Isle of Man. If you're watching, this is your power supply. Don't be horrified by the fact that this is a £3,500 repair, because that's what I would normally charge. But this is a project for YouTube. And as well as a long drawn-out repair video, it's also an opportunity for people to get some technical explanation of how these things work so they can fix them themselves. Alright, okay, so that's what she looks like now. I'm going to whip those diodes off. I think they're not connected to anything because all the circuitry's gone from up there. Alright, so yeah, I'm going to go and bake it and then I'll be back. Hello everybody. Yeah, so we've got the board. It's been baked overnight, 105 degrees for 10 hours to get rid of all the volatiles from it. Smells different actually. The smell is gone. It's interesting. And here's the power supply we made. It's a bit of a lash up, but it's safe and it's fused and it's thermally protected, and I shall put some more silicon on it when I'm finished. So that's our 15 volt off board power supply that replaces this ridiculous linear dropping system that comes from the actual rectified mains voltage, the 320 volt rail. So we've got everything mounted as we've shown, and there's a wire in there to replace that track that wire had gone. It actually went round here, didn't it? That's right. So there's wires here. I've done just about everything I can to try and work out that this is going to work. I've done everything I can reasonable to ensure this is going to be okay. We've run it without the FETs in. We saw the signals, you know, put the FETs back in, put the balancing on. So time to try it, I guess. The power comes into this IEC mains connector via a isolating transformer, and more importantly at this stage over there we've got a, I think I've mentioned this before but I'll show it to you again. This light bulb is in series with the live, so that if we get a short on here we get a light lighting up. The resistance of the, I'll measure it for you now actually, the cold resistance of this filament in this bulb is 143 ohms. So I've got basically a 100 ohm resistor in series with the mains. So that if there is a short on here, rather than getting the full mains inrush current coming in and things exploding and another catastrophic wipeout of the parts I've just fitted, something might just get hot, or it'll just lead us on to another level of investigation before we reapply the power. So it's all connected up. These wires here are the wires that go down to this power supply. I shall put them inside an insulated sleeve and then tie wrap them to the board when we know what length they've got to be when it's being reinstated onto the chassis itself. This is a ground wire. This is a AC 0 volts wire for my meter or scope probe. I don't need it for my scope probe at the moment unless I have to do some probing. Alright, so if I move that back there, I honestly haven't time to turn this on yet, but I just wanted to share this moment with you. It's always, you know, it's not like turning on a logic circuit and see whether the, you know, you get the right number from it or it's communicating. This is usually a tense moment in any repair, so the legwork you do before you actually get round to turning it on is most important actually, because then you've got some confidence. Again, if you don't know what you're doing, don't run these things out of the case because they can give you a nasty shock. Alright, so without further ado, power meter up. There's a Yokogawa power meter up there. I can see the power factor, I can see the watts, the current and the voltage, so I can tell whether we've got a reasonable power consumption when the thing's just idling. There's no DC loader connected to this at the moment, but I know from experience they do idle okay. Alright, so let's just turn it on. Okay, so we're taking 17 watts, power factor 0.38, 252 volts, which is a little bit high. I'll turn that down a bit. So nothing catastrophic happening just yet. Let's see if we've got any switching going on. You can see on the scope, yeah, that's switching. Yeah, we've got a big signal on there. That's 50 volts per centimetre. So, okay, so it's running now. So if I just hold the scope on the transformer, you can see you're getting, that's just inductive pickup of the transformer's flux in the transformer. We're taking 15.7 watts, which is a nice low quiescent current. Let's put this on to something like 50 volts per division, and we'll meter the gate of the low side FET, and you can see, ooh, look at that. There you go. So that's what I'm seeing on the scope there. So we've got a nice nice square wave on the what frequency is that going at actually? Out of interest, measure on frequencies, 41.7 kilohertz. So it's quite a low frequency power supply, 41.7. All right. So that's that. So that's working. So let's finally just do a DC voltage check on the output. DC across the output reservation or reservoir. Let's do a measurement across the output reservoir capacitors. Put this on volts first. Might be useful, mightn't it? Move that out of the way. Minus 49. That's lovely. Actually, if I do it around that way. Anyway, so it's working and it's repaired. I'm just going to put it back together and test the other parts of the amplifier. If anything interesting comes up, I'll let you know. Be interested to know whether you think this has been too long-winded and boring, whether it was entertaining or whether it was just too slow, whether I should leave lots of sections out to make it more concise and punchy, or whether you really do want to see the whole repair process, including the thinking processes that go into getting something like this working, the things to check. Yeah, so that's that. Let me know, and if you've got a 518S that needs any love and attention, then and you want some help repairing it, then I'm happy to advise within reason. And if you can just go down the corner of the screen here to the subscribe button and hit the subscribe button and hit the notification bell and leave me a like, I'd like that a lot. So anyway, that's me signing off, and yeah, 518S power board restored.